Well, if we kind of start with the same steps that we did before, with this function we kind of want to look specifically on the interval from 0 to 2 pi. We want to kind of talk more about the domain. So if we look at the domain, cosine between 0 and 2 pi, everything looks great because cosines will either be 1s or 0s, so we're okay. On the sine value, what sine will actually either be or 1s or 0s, but still nothing there is going to be undefined. In other words, we don't have any fractions. If we had the secant or the cosecant function, we have to worry, or the tangent or the cotangent, but not with these two guys. So it looks like the domain could be all real numbers. But specifically, obviously, it's not all real numbers. They want us to narrow between 0 and 2 pi. Okay. So the next thing we want to do are our intercepts. So how about our y-intercept? The y-intercept is when x is 0. So it's going to be y is equal to the cosine of 0 plus the square root of 3 times the sine of 0. Cosine of 0 is 1. Square root of 3 times the sine of 0 is 0. So at y equals 1 is our y-intercept. For our x-intercept, we have 0 is equal to cosine x plus the square root of 3 times sine of x. And like sometimes in the past, the easiest way to almost answer the question on the x-intercepts is to really analyze what the equation is saying. I want to be able to take the cosine value of an angle, add on the square root of 3 times the sine value, and get 0. Okay? So I'm thinking about just general coordinates that we have on the unit circle. Like we have 1/2 square root of 3 over 2. That happens at pi over 3's. And then we have square root of 3 over 2, 1/2. And those happen at pi over 6's. Let's look at this. If I multiply this y value right here by the square root of 3, would I get over here? Not so much. You would get 3 over 2, but not 1/2. So we're going to throw out this one, but come to this guy right here. If I multiply that y value by the square root of 3, wouldn't I get that x value? Okay, so now we're kind of headed there. We want to work with the pi over 6's, but I need to be able to add these two together and get 0. So we really don't want them to be the same. We want them to be opposites, like in a sense of if this one was negative, or if we had the 1/2 as being negative. So that way, by the time I multiplied these two by the square root of 3 and then added them onto the x, we would actually get 0. Okay, so in the sense of we're talking about in quadrant 2, what is pi over 6's version, or what's its coefficient, or what am I trying to say? What is its equivalency? There we go. What is its equivalency in quadrants 2? And then this one right down here would then be quadrant 4. Well, in quadrant 2, that would be an x value, let's see, of 5 pi over 6. And then in quadrant 4, that would be an x value of 11 pi over 6. Okay, so those are x-intercepts. Okay, we've got those points, those key points. So the next step we want to do is go back to our main function, and we want to find the first derivative and the second derivative off of that. All right, now taking the first derivative of this function, we'll get y prime equal to derivative of cosine x, which is a negative sine x, plus the square root of 3, and then the derivative of sine of x is cosine of x. Setting this equal to 0 so we can find our critical points, we'll get negative sine of x plus the square root of 3 cosine x. And if we kind of do what we were doing in our last part where we were finding the x-intercepts, we do the exact same thing. We have potential coordinates of 1/2 square root of 3 over 2, or we can do the square root of 3 over 2 and 1/2. Okay? And then this time, if I multiply square root of 3 times our x values, should I do it to that one to equal the y, or this one? Well, obviously it's going to be the top one. Okay? The square root of 3 times 1/2 would be the square root of 3 over 2, and they match up that way. And this, because the sine of x is negative this time, that it actually works in quadrant 1 and quadrant 3, to where if I plug them in, that'll actually get 0. Because as is right now, a negative plus a positive will give me 0. And then in quadrant 3, when it's a negative and negative in both, that'll become a negative there, but a negative negative is positive for the first. Okay, so then it'll be a positive and a negative and go to 0. So this point right there, that critical point, is going to be x is equal to pi over 3. in quadrant 1, and then in quadrant 3 it'll be 4 pi over 3. Let me go and do x equals 4 pi over 3. Okay, so there's our critical points, and let's go about getting our second derivative. So let me erase some of this work. And our second derivative. Okay, so y double prime is equal to, a negative derivative of sine of x is cosine x plus the square root of 3 times the derivative of cosine x, which is negative sine x. So y double prime is equal to negative cosine x minus the square root of 3 times the sine of x. Okay, it looks like we are pretty much back to exactly our x-intercepts here. We want to figure out where this is going to go to 0. And the coordinate that we used there that worked out great was the square root of 3 over 2, comma 1/2, which is a version of pi over 6, because there, now I'm taking the y value times the square root of 3. So if I take that right there, multiply by the square root of 3, we get these two to be equal to each other, which is great. And then right now, they're both of the same sign, so we got to think of our answers. Instead of being in quadrants 1 and 3, we got to go back to quadrant 2 and 4. Okay, so let's give our answer, our version of pi over 6 in quadrants 2 and 4. And those are going to be then x is equal to, in quadrant 2, 5 pi over 6, just like our x-intercepts. And then x is equal to 11 pi over 6. All right, so now I think at this step we're ready to start getting into our sign chart so we can see about our intervals of increasing and decreasing, and then also about our concavity. So let's do one sign chart for our first derivative. Let's do one sign chart for our second derivative. On our first derivative one, we're going to have the critical points of pi over 3 and 4 pi over 3. And on the second derivative, we'll have our points of inflection of 5 pi over 6 and 11 pi over 6. Okay, so let's test these. Once you pause it for a second, y'all test these points. I'm going to test these points. Let's see if we get the same plus or minuses. Okay, so putting all this together with the plus and minuses, hopefully y'all got the same. I went ahead and added there what values I tested with. I just did it really, really simple because I did zeros and pi's, and that way it wiped out either the sign pretty much, and all I had to do is focus on the cosine part of it all. Okay, so let's form ourselves a graph. Here's my x and y axis. I'm pretty much going from 0 to 2 pi. So if we make this pi right here, we make this 2 pi. Here's pi over 3 pi over 2 and pi over 2. So our x, we have a y-intercept up at 1 for one thing. We have our x-intercepts at 5 pi over 6, which is going to be right about there, right before pi. And then we have another one at 11 pi over 6, which is right before 2 pi. Okay, and then we have, let's see, our critical points at pi over 3. So pi over 3 would either be a max or a min. And looking to our chart right here to tell us, it looks like we're going from increasing to decreasing. So at pi over 3, we're going to have a max. And then from decreasing to increasing, we're going to have a min. Okay. Down here, that's concave down, concave up, and then concave down. So some other ideas to keep in mind when we're drawing this graph is all the different concavity. And then at 5 pi over 6 and 11 pi over 6, so at those x-intercepts, we're going to be swapping concavity, changing directions there. Okay, so at pi over 3, if we plug it into our main function to actually see what's going to come out, our main function, looking at it right here, the cosine of pi over 3 is 1/2. So a half plus, and the sine at pi over 3 is the square root of 3 over 2. So combining this together, I'm just trying to get a rough value so we can actually graph it for us. And what's going to come out is a value up at 2. So we're basically going to be, if that's, let's see, pi over 2, so we're going to get right about in there. Okay. And then a min at 4 pi over 3. So there's, we should get a y value there at -4, or at 4 pi over 3 down there at -2. Okay. So my graph Just following my increasing and decreasing, should be increasing up to pi over 3 to get my max. It should be decreasing all the way down to 4 pi over 3 and then increasing past that. Okay, and we're going to stop at some point, obviously, because our domain ends at that point. Looks like at 2 pi, it's actually going to end at 1. Okay, and then let's check. Should be concave down all the way through to our first x-intercept, which is great. And then we should be concave up all the way the rest of the way. Oh, I'm sorry. And then after our next intercept, we should be concave down, which makes sense because we're starting this second curve going back around. Okay, so right there is a graph of our function.